And we're continuing the intermediate value theorem, section 1.7. This is exactly where we left off. I hope everything has made sense so far. Please don't forget to reach out to me if you have any issues. So moving forward, I felt like that was a great place to stop, by the way, because this is a very different problem. In case you've forgotten from last year, an exponential function always looks like this. Now it could be flipped, reflected, and things, but the point I'm making is it's continuous everywhere. If you have not seen the cosine function yet, again, since we missed it last year, it is a continuous function everywhere. It has this harmonic motion to it. But the point being is when you multiply two continuous functions together, it'll still be continuous. So this function, p of x, is continuous everywhere. But we only need to worry about is it continuous from -2 to 1, and that answer is yes. Maybe put it like a check mark right there. So the next thing that you would want to do is figure out what p of -2 is. All right, so p of -2 is plugging in -2 in for both those x's, so we're looking at e to the 0 power times cosine of -2. Now e to the 0 power I expect you to know is 1, but cosine of -2 is not an exact value on the unit circle. You can actually see the last thing I wrote out. Make sure you're in radians, by the way. We are. So cosine of -2 is this, -0.416. All right, round to 3 decimals. Please don't forget about that. Let me change colors to find what p of 1 is. Well, p of 1, we're plugging that in, so 1 plus 2 is 3 times cosine of 1. I do not expect you to know either of those in your head, because e to the 3rd power is not a pretty number. So e to the 3rd power times cosine of 1 is about 10.852. So as we look at this, it is continuous, check. Is 5 between our two bounds? Yep. So the intermediate value theorem applies. There is a value for c between -2 and 1 such that when you plug it in you'll get 5. Now how do you find that value? Well, this is not a pretty problem. Okay, you're not going to be expected, at least from me or at all this year, to be able to do this type of problem in your head. However, you're allowed to use a calculator. So let me show you with the graphing calculator, at least my graphing calculator, is what you can just do is go to your y equals and type in the equation, second e to the x plus 2. If it helps, write out times cosine of x. And then create a second equation that says equals 5. Now, we've already shown with the intermediate value theorem that our answer will be between -2 and 1, so you can change your window to be from -2 to 1. And if you, it's a neat trick, if you hit zoom and go down to 0, the 0 option says fit, and it'll fit that graph perfectly, and you can see exactly where the equation we came up with hits. So now you can hit second trace, it will calculate. I'm going to hit 5 for the point of intersection, and then just scroll over to where you're looking for and hit enter 3 times, and you can see it's about -0.334 when we round to those decimals. So the c value is about, because we're rounding, -0.334 is what we're looking for. And again, feel free to pause the video or go back and rewatch how to click those buttons. Just moving forward, I think it's just more of the same thing. Sorry if yours didn't print off the way mine is supposed to look, but anyway. The only issue with this is that x cannot equal 2. because then we'd be dividing by 0, but 2 is not within this interval, so we can sort of ignore that statement. It is, this rational function is continuous on the closed interval, so we're good to move forward. Now what we need to do is figure out what f of negative 1 is. So when you plug in negative 1 on top, negative 1 minus 2 is negative 3, so we're looking at 1/3 there. And then f of 1, so you get 1 on top, 1 minus 2 is negative 1, so we're looking at negative 1. So the question is negative 1/2 between these two values? And you would say yes. Now maybe I should, so the IVT applies. I should have earlier actually written out the inequality because students got this marked wrong on the AP test. So listen closely. You can do one of two different things. You write negative 1 is less than negative 1/2 is less than 1/3, or you could write it f of 1 is less than negative 1/2, which is less than f of negative 1. Either one of these is correct. Where students got marked wrong, let me write this in red, is they wrote it this way. F of negative 1 is less than negative 1/2, which is less than f of 1. Well, the problem was f of negative 1 is 1/3, and 1/3 is not smaller than negative 1/2. So as a person grading, I had to mark this wrong, even though they clearly understood everything. I just have to apologize. That's kind of the nature of the beast. And I will admit, I marked students wrong and I did that. But to finish this problem, all you have to do now is set up the equation and set them equal to negative 1/2. And then our answer should be bigger than negative 1 but smaller than 1. Let me scroll down a little bit. Because all I would do is cross multiply, if you want my opinion. And don't forget to distribute this negative 1 to both of those x's. So negative x plus 2. So add x over, that would be 3x is equal to 2. And then divide by 3, you get 2/3 is the c value that we're talking about. Now, I am fine that you write x equals because the c value is an x value, so it's evident in the problem. Now, if you look back at the directions, it's saying what's the c value specifically. So maybe a better teacher would actually change these x's to be c's. So these would be c's, so then right here is a c. But kind of like my argument earlier, that they wouldn't make a big of a deal about this because this is still a true statement, whereas what was written up here in red is a false statement. So make sure as you're writing things out, the variable doesn't really matter, but the mathematical truth does. So try to keep that in mind. I mean, sometimes it's difficult because they might change their mind halfway through a day to accept this for full credit, but they didn't. So as a warning for you. Here's another problem that's an exponential. So exponentials are continuous everywhere, so nothing to check. I guess I should say continuous on all reals. So it's just safer if you just give them the words that they give you. So continuous on the closed interval. So then you try your lower bound, f of 3. Probably would be faster if you just go to your calculator, except negative 3 plus 3 is 0, so anything to the 0 power is 1. Negative 1 minus 2 would be negative 3. And then f of 5, I might as well just go to my calculator. And I've shown you this trick before, so I might as well just do it. Go to y equals and just type in these equations. I already forgot what it was. Negative of 1/2 to the negative x plus 3 minus 2, And then you can just go back to your home screen, alpha trace, so you can grab that equation, and parenthesis 3 to confirm that my answer was correct earlier, -3. And then do the same thing with 5, and you can get -6 there. That could have been done. I don't know what I was thinking. Okay, so how would you write it using this lingo is since f of 5 is the smallest of these two values, you'd say f of 5 is smaller than -4, which is smaller than f of 3. This would be the correct way of writing it. So the intermediate value theorem applies. And again, a better teacher might write it this way. -x plus 3 minus 2. I said a better teacher, then I didn't even do it. Change the x to a c value because they're asking for f of c is equal to -4. So you don't need a calculator. Let me just show you what it would look. Add 2 over. So that's -2. Divide both sides by -1. So just to save some time. The right side is the same thing as 1/2 to the -1st power. I hope you all agree that 1/2 to the -1st power equals 2. So then the bases are the same, so that means the exponents must be the same. We did all of this, by the way, in pre-calculus. You just may have forgotten. And divide, you get c equals 4. But don't forget that your calculator will do all of this math. I think you should be ready to do the assignment now. And good luck.